What's good, everybody? Welcome back to Algebra-1 with Mr. Peters. Today, I have a very special three-part video on how to simplify radicals. We're going to look at simplifying radicals with variables, numbers, and both. Let's get started for today. In the first part of this video, guys, we're focusing on simplifying radicals with only variables. And there's some important things we need to know. So first off, if it's just x to the first power, we can't take the square root of that. So we would have the same exact answer, right? Just the square root of x. But once we get to exponents of 2 and higher, the problem or the answers change. So let's look at x squared, right? X squared is the same thing as if they're asking us to take the square root of 25 or the square root of 5 squared. What exactly do I mean? So if you look at x squared, right, its square root is just x. And if we look at this bottom example here, all that changed was the base. So 5 to the second power is 25. We know that the square root of 25 is 5. And we know here, right, if we have an exponent of 2, we're just going to take the base by itself. Now, how does that apply to variables? Glad you guys asked. So let's look at x to the 7th, right? So we know that every time we have x squared or we have a pair, right, we are able to take the square root. So let's look at how we could do this. So the best thing is to always take the highest even exponent, and I'm going to show you why. So we have x to the 6th times x to the 1. Or we could have x to the 4th times x to the 3rd. Or if we broke it down, we could do x squared times x squared times x squared times x. Now, what I want you guys to know is all three of these are correct because when we add our exponents up, we will get x to the 7th. However, the best option is the first one. Once we get the highest even exponent by itself, it's so much easier for us to solve. So let's look at x to the 6th. X to the 6th, and let's switch colors. This is going to turn into x to the 3rd power times radical x. This should be our final answer. Why? Let's break it down, right? So when I split this out, x squared, its square root is x, right? X squared, again, square root is x, and x squared square root again is x. And then this x that's just to the 1st power, it stays under the radical. So now, once I simplify, x times x gives me x squared times x gives me x to the 3rd, and that radical x stays by itself. So this is why we want to use the largest exponent, because it's going to be less simplifying, which means less steps, less mistakes. So in this last example, x to the 4th turns into x squared. When we look at x to the 3rd, we're going to get a x times radical x, right? Because we had one pair, comes out as x. Now, once we combine these answers, we're going to get x to the 3rd radical x. Now that we have that down, let's go through a few more examples. So, like we said in the previous examples, with this, let's just split it by having the highest even exponent. So I have x to the 4th times x. I know when I break this down, I'm going to get x squared. This stays under the radical, and this should be my final answer for x, the square root of x to the 5th power. Now, once we go to our next one, even exponents are pretty simple. Whatever our root is, right? We have a root of 2. We're going to divide that exponent, right? How many pairs of 2 do we get in 14? X to the 7th power. That's its answer. Now, when we go back to odd exponents, let's just split this and we're going to use this as a reference. So x to the 15th power is x to the 14th power times x, highest even exponent. When I simplify now, x to the 14th turns to x to the 7th. X to the 1st cannot simplify, so we keep it the same, and it's under the radical, and our answer is x to the 7th power times radical x. Next part of this video, guys, we're not going to work on simplifying just numbers under the radical. Second part of this video, guys, we're focusing only on simplifying with numbers under the radical. But I am going to refer back to the first part of this video. So when we look at the square root of 7, right? That's like the square root of x. We can't break it down anymore. There are no factors, no numbers that we could divide 7 by, and those factors are perfect squares. So this stays the same, similar to just the square root of x. Now I get over to 49. And remember, 49 is a perfect square. That's basically 7 to the second power. So how do I simplify? Answer is 7. So imagine if we had the square root of x squared, this is x. So now just showing you how this is as a number and how it is as a variable. This is the same concept, right? All they did was switch 7 with x or x with 7. Now, guys, let's say we go through and we don't have perfect squares, like 45. So when we talk about factors, those numbers we divide by, we're looking for a perfect square. So we're looking for something like 4, because its perfect square is 2. We're looking for something like 9, because its perfect square is 3, or 16, whose perfect square is 4. So when I look here, the largest perfect square is 9. So let's break it down. This is going to turn into the square root of 9 times the square root of 5. And when we look at it even further, perfect square comes out. Our answer is 3 radical 5. Now let's say we go to 72. And I'm going to show you guys why you need to always use the largest perfect square. So 72, a lot of students like to use 9 times 8. And what happens here is we simplify 9 to get 3 radical 8. But now 8 has to be broken down more, and this is going to be 3 times the square root of 4 times 2. Now we take the square root of that. 3 times the square root of 4 is 2, times the square root of 2, and our final answer will be 6 radical 2. But hey, look here, y'all boys and girls. I love y'all, and I want to make this as easy for you. We can't waste time doing that many steps because we're bound to make a mistake no matter how good you are. So here's my thing. This is why you have to use the largest perfect square. So let's say I remember that the largest perfect square is 36, right? Look how simple this becomes. Oops, sorry, rushing. So we have 72, and we break this down as the square root of 36 times 2. And we know that 36 is a perfect square. Breaks down to 6 radical 2. That is our final answer. But before we go, guys, like this video if you do find it helpful. Subscribe to the channel, leave a comment. But we're now going to combine both of these sections in part 3. Please make sure you stay to the end. Last part of this video, guys, like I said, really hope you found this video helpful because this is what we do it for. Make it easier for you guys. So first example, it says they want us to simplify 81x to the 4th power. So guys, we know that 81 is a perfect square, right? Square root is 9. X to the 4th, we have an even exponent. So how many pairs of 2 do we have in 4? That's 2. So we're going to have 9x squared. That is our final answer. Now we have the same exact problem, but they changed the exponent to an odd one. Does that really change the problem? No, 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 no. Let's say we just wrote everything out, right? So let's write this all out. We have 9 squared times, and we followed Mr. Peters' rule, right? Split it with the highest exponent, even exponent. So now, right, 9 squared, what's the square root of that? It's just 9. So we have 9 on the outside. X to the 6th turns to x to the 3rd, right? Divided by the root. Root is 2. And now x to the 1st power, we cannot simplify it, so it stays under the radical. So this would be our final answer. All right? Now let's say we go over to a non-perfect square such as 44. How would we break it down? The same exact way, guys. So we know the largest perfect square that goes into 44 is 4, right? So we have 4 times 11 times x to the 8th times x. And guys, students write this different under the square root. Whatever works best for you, do what works best for you. This is what Mr. Peters likes as he teaches it. So here we go. Perfect square turns into 2. Perfect square, x to the 8th, turns into x to the 4th. Now what happens to the rest? Non-perfect square, can't simplify, stays under. X to the first, we can't do anything with that, so it stays the same. And this is our final answer. 2x to the fourth times radical 11x. Now let's say, guys, in the last example, same exact thing. But now they give us two variables. It's the same process. So what do I mean? Let's go through it. So we could divide 96 by 2. Let's see. We could do 2 and 48, but like I said, guys, that's not the best choice. The largest perfect square that goes into 96, I believe, is 16. So let's draw out our factors, right? We know 16 times 6 gives me 96. X to the ninth, I'm going to split as x to the eighth times x to the first. And luckily for us, y to the fourth, right? We can leave it as y to the fourth, or I'm just going to change it as y squared times y squared, just to give you a different way to look at it. So now we go back, perfect square turns into 4. Perfect square, x to the fourth power. Perfect square, y. Perfect square again, now this is y squared. Now what we have left over is our 6x under the radical. So we really hope that this simplifying radicals video was helpful for you guys. Thank you so much for joining us today on Algebra 1 with Mr. Peters. Smash the like button, subscribe to the channel, and leave comments for future videos you guys would like to see on our channel, or if you guys had questions on today's video. Thank you so much for watching us today.